right, so we have two circles and rectangles. So let's do our two circles first. Well, the area of a circle is just pi r squared. So if I have two circles, it'll be 2 times that pi r squared. So that'd be times 5 squared. 5 times 5 is 25. 25 times 2 is 50 pi. So my two circles area is 50 pi. The rectangle, ooh, that does not say rect. Missing an L. There we go. My rectangle, I need base and height. Well, I have the height is 20. So let's say that this is 20. Can someone tell me how to get this width? Since I was not given the width. Yes?
Circumference of the circle.
Perfect. Yeah, so it's the circumference of the circle, so that's 2 pi r, right?
Yeah.
2 pi times 5, so that would actually be 10 pi. So the rectangle's area is 10 pi, not plus, but times 20, so that's 200 pi. So my surface area, I'll just call SA, is going to be 250 pi. Do we have centimeters? Yes, we did. Centimeters squared. Any questions on my surface area? Sometimes I find surface area the hardest one because you actually have to find all of the parts. Where volume is just find the base, multiply it times the height. So even in that little bit of room, I could probably do volume. I'm not going to. I'm going to go ahead and erase all this just so I have a little bit extra room just to do the volume, just so we know we're switching over to volume. So we have the big volume, and volume is basically our base area times our height. Grace.
So to find the base area,
Mm-hmm.
you do pi r squared, which is pi times 5 squared, or like, yeah, so 25 pi
Mm-hmm.
times 20, which is the height,
Mm-hmm.
and then you get 500 pi centimeters cubed.
500 pi centimeters
We should bring pi in someday.
cubed.
Can I bring pi?
You sure can.
Wow.
All right, so we have 500 pi centimeters squared. Questions on volume or surface area? Like I said, I think volume is a lot easier than surface area because surface area you have to find all of the parts that make it up. Volume is just find the base times the height, and we already talked about cones. We talked about pyramids, which is just the third of that base area times the height. That's pretty much as complicated as volume gets. If you looked at the homework, we just had the harder problems were the ones where I combined like a couple shapes. But as long as you separate it into your two shapes, then you should have been good. One last chance for questions on this. Okay, let's go to questions on the homework. El Treso's homework. Sabrina. The last one. So number 14 says determine the volume of the solid formed by rotating the shaded figure around the y-axis. So we had I'll draw kind of what was going on. So we had a line like this. Let's say this is my y-axis. This is my x-axis. This was the point on the y-axis or x-axis 1, 2, 3. This was the point 2. So the question was, what happens if I revolve this around the y-axis? So what we're kind of picturing is, Sabrina, I bring this all the way to the other side, creating a figure. Kind of think about it just spinning and making a solid object. So that would look like, so if I just did this to the other side, we'd have a shape that looks something like this. Maybe I'll extend that x-axis. But it'd also be all of this area here, because I'd be revolving it. So it'd be all of this. So what, in fact, I'm creating is a cone. I'm creating a cone like that. Well, define the volume of a cone. So it just says determine the volume of this cone. I just need the base area. Bless you. I need the height, and a cone is 1/3 of that. So since this is a cone, not a comb, but a cone, the volume is going to be the base, or 1/3, times the base area times the height. Well, that's 1/3 pi r squared. But rather than doing r squared, I'm just going to look at this. This is my radius, right? From here to here. Well, that's 3 units. And the height is 2 units, right? So it's just pi r squared. Once again, that's just pi times 3 squared. Times our height. Our height is just 2. And that's going to come out to 6 pi. I should have been units cubed, actually. But we didn't have units to it, so I'm just going to go 6 pi. Does that make sense? Do you see the cone I created? So I didn't mean just like flip this to the side and see what happens. It means like you're constantly flipping it, you're creating that solid object.
So when there's a question like that, you just like make a shape based?
Yep, you make a shape based upon how it. So let's say I had a square here and I said revolve that around the y-axis. It would actually make a bigger, it would make not a cone, it would make a cylinder of sorts. All right, just picture it being flipped all the way around. All right, other questions? Akshay.
The one before that.
The one before that says the conical shaped container shown to the right is being filled at a steady rate. The time in seconds it takes to fill the container to the top of the graph at the far right, as you see in the graph, because the container is not uniform in the radius, the height of the water does not increase in a linear fashion. So anyways, I'm trying to see if I have any container around here that matches that shape. What was that? No, that's all. That my bottle would be linear, right? If I put water in it, the height would go up at a steady rate.
No, I meant that one.
Oh, this one? Yeah, well, this one matches my next one, right? This kind of matches the next shape that we have. Let me take a picture of it, and we'll discuss it from there. So we have this shape. And what I did is I turn on the faucet. And I just leave it at a certain rate. Well, down here it's going to fill up really quick. Right? Because it's a very small space. It's going to fill up really quick. And then it's going to start slowing down as we get up here, because it's going to take more water to get higher and higher and higher. So that's what's shown here. It gets off to a quick start. And then it starts slowing down. The height is going higher and slower, 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 slower. Does that make sense, Akshay?
Yeah.
Okay. My next step is basically invert it. We're going to have that same container, but now it's upside down. I wonder if I could. Let me try something. Because I kind of have the answer there. Okay, so now we have this shape. And I turn on the faucet, and it starts filling up. Well, at first it's going to be really slow because it takes a lot of water to move this up, right?
Oh, did you just like make like the first thing we had up there except upside down?
It's pretty much upside down, yeah, because as I fill the water, it's going to get faster and faster and faster and faster, right?
Yeah.
And so the shape of the graph is going to be slow to quick. So once again, as I'm putting water in, it starts out really slow. And then as I get near the top, it goes faster and faster and faster and faster. Does that make more sense?
Yeah, it's a lot easier than I thought it was.
Oh, okay. And if I would fill up this water bottle, Akshay, if I was doing my water bottle, which has a uniform shape up and down, it would just be a straight line. The height would move at the same pace as I fill it up.
I would say it would move because like at the top, like
At the very top, right? Because it would all of a sudden you'd see like a quick uptick.
yeah.
Yeah. So at the very top, but most of it would just be kind of a straight line. And then at the top, it would just quickly increase at the very end. Yep. just like this one would kind of be linear. Well, we kind of have if we look at this soda bottle, it'd be kind of slow at first, and then it would pick up speed, and then it would slow down a little bit. If you can see that, there's a little notch out of there. And then it would slow down just a little bit, and then it would pick up pace to get to the top, because the top would be quicker and quicker and quicker. Lydia? Yeah. Are there any more questions on this one? Yeah.
So is it basically you just want us to create a graph?
Yep.
Oh.
Sketch an approximate graph. Yep, that's all I wanted. Any other questions on this one? All right, Lydia asked about number 11. Number 11 was a period has a regular pentagon for a base. If the pentagon has sides of 13 centimeters and an apothem of 4.7 centimeters and the height of the pyramid is 18 centimeters, what is the volume of the pyramid? Here's the nice thing. I gave you all the information you needed. You actually didn't need to find anything because I'm pretty nice like that. So we have a regular pentagon for a base. And it's a pyramid. Well, for a pyramid, the volume of a pyramid yeah, it was a pyramid. That is going to be 1/3 the base area times the height. So volume is always going to have something to do with base area times height. With volume, pyramids and stuff and cones, it's going to be 1/3 of it. But we always got to think base area and height. So anytime I ask volume, at least find the base area and try to find the height. At the very least, if you don't know how to do anything else, at least find that. Well, in this case, our base area, so that's a pentagon. To find the area of a pentagon, that is our 1/2, our apothem, times our perimeter. So let's throw that into the full equation. So we'd have 1/3. Maybe I should put these in brackets. 1/2 our apothem, but they gave us our apothem, right? They said our apothem is 4.7 centimeters. So we're going to 1/2 times 4.7 centimeters. That's my apothem. And then our perimeter, well, our perimeter says that it is supposed to be, we have sides of 13 centimeters. 13 centimeters is not my perimeter. I have to do 13 times 5 because I have 5 sides, right? So that's going to come out to 65. That took care of that. Now we're going to multiply that by the height. Our height was 18 centimeters. And you plug that in your calculator and you come out to 916.5 centimeters cubed. Does that make more sense?
Yeah.
You sure?
Yeah.
You still look angry at it. Positive.
Yeah.
I don't want to move on and then you're like, I don't. We're good?
Yeah.
Okay. Other questions? Other questions going to funds?
This is about
Tonight's homework, did we even have a chance to work on tonight's homework yet? Grace?
for number 14, so can you just like explain like what the figure, so is that like, I'm just a little confused about which one to solve for.
For
Like the
tonight's
triangle?
or?
No, from yesterday, for number 14.
We did 14 in class.
Oh, okay, sorry, I missed it.
Yeah, we did 14 in class.
So we use the, okay.
Make sure we're paying attention. Spent a good 3 minutes on that. Other questions? On tonight's homework? Is it a good question? What's your question?
So on number 4,
Oh,
these are making the cylinders. Are we assuming that the tops are still like, because they're
there is no top.
Okay.
Wait, we're trying to find surface area or volume? Well, yeah. Then it's so volume doesn't matter if it's top or bottom, because volume is just how much I could put in here.
Okay.
Like if there was a bottom, how much can I put in there? So volume can't be can't be 0, because if there was no top or bottom, it'd be 0, right? That's what we're looking for. So we're just assuming that I can put something in here. How much stuff can I put in here? Does that answer your question of sorts? Surface area though would be different. If I asked for the surface area, you wouldn't have to do the surface area of the top or the bottom, because that doesn't exist.
Wait, but to find volume, though, we need the base area.
We do need the base area, but we're just pretending there's a base there.
Okay.
There's still a hypothetical base there.
Oh, right.
Okay? So volume really doesn't care about top and bottom. It's kind of like a paint can, right? It just has a bottom.
Oh, sure.
But you can still put paint in it all the way up to the top, even though there's no top.
Okay.
Yep. So volume does not matter if you have a top or a bottom, only surface area does. Yes?
For number 5, what do you mean by